Um, so we have this every month, and we've been having, especially the past 2 years, very exciting speakers from inside and especially outside of UF. So it's my pleasure to welcome Josh Hartshorne today to talk about his most recent research. So Josh got his PhD a while ago at Harvard and then went on to become a postdoc at MIT working with Josh Tenenbaum, and is now a professor or assistant professor of psychology at Boston University. Sorry?
Boston College.
Sorry, Boston College. I'm sorry. It says in my notes, Boston College. I'm so sorry. Josh became famous, very famous, because he was one of the first to apply these what are called massive online studies to study questions related to linguists. Related to linguistics, sorry, that are of important to language researchers. And his 2015 paper was the start of a series of papers on that topic. So since then, his research has progressed, of course. So I'm very happy that he is here to talk about his recent ideas, especially on the critical period. So just before we get started here, so just so you know, this lecture will be recorded, already is recorded. So if you don't want to be in the recording, please switch off your video, etc. All right, so please help me welcome Josh Hartshorne.
Thanks. And I am something wrong with my screen. So just a second.
Yeah, it's kind of dark right now. Yeah, there we go.
There we go. All right. So yeah, thank you for having me. And I want to start with talking a little bit about how we, the field has looked at and studied critical periods before, right, in language. So studies tend to involve looking at something like this, which is I'm going to call an ultimate attainment curve, because what we're looking at is proficient speakers of a language and comparing their current knowledge of the language against the age at which they started learning the language. So here, this is my 2018 paper, and this is all syntactic knowledge, so morphosyntax. And what folks have generally been interested in doing is seeing whether these curves match one of three sort of shapes, right? So this is from a paper by David Birdsong, but you see similar things in, like, say, Hakuda, Bialystok, and Wiley, and so on. So you have, like, here for A, this stretched L shape where we have a decline from birth, right? The older, every day later you start, you do a little bit worse until you hit some sort of floor. And after that, it doesn't really make any difference. Or in B, the stretched 7 shape where you have, let's call it an optimal period for learning, right? As long as you start before some age, let's call it X, it doesn't really matter, you'll, hit ceiling eventually. But if you start after age X, then you have a decline. Or then you have sort of like a combined, stretched Z shape, which is the last curve there. And so, it should be pretty obvious, the figure I'm showing you here looks an awful lot like the second option, the stretched 7 shape. Now, unfortunately, and it looks like, basically, as long as you start before about the age of 10, it doesn't make a big difference, right? And this is true for both the immersion learners. These are immigrants who started learning English around the age of immigration. And for non-immersion learners, who are people who don't live in an English-speaking country, never have, but have learned English. Obviously, the immersion learners, the immigrants, do better. But within each group, it doesn't seem to matter exactly when you start, as long as before about the age of 10. So like, case closed, do we know what's going on? So actually, as I looked at this graph when we first made it, I realized the implications weren't at all what sort of we as a field had thought the implications were. In fact, I realized there wasn't actually really any theoretical implications from a graph like this at all. And let me explain that to you. So imagine, let's say I assigned a paper on critical periods for some seminar that I'm teaching. Students start reading the paper at different times on the day of the seminar, and we chart how much of the paper they finished based on when they started. So maybe it looks like this. All right, well, we have this bend here at, a little before 10 a.m. So we want to say, there's a critical period for reading this paper at 9:30 a.m. Actually, what's going on is the seminar starts at 1:45, and the paper takes about 4 hours to read. So if you didn't start by 9:30, you're basically out of luck, right? You're not going to finish it. And people, as we all know, generally, if they haven't read the paper before the seminar, they never read it. So, starting after the start of the seminar is not a thing that really happens. Now, of course, if I had assigned a shorter paper, then the curve might look different, right? So if it was a paper that takes an hour and a half to read, then we would see, a quote unquote critical period at the age of at like 12 p.m. But really nothing was happening at 9:30, nothing was happening at 12. The only thing interesting is happening is actually at about 1:30, 1:45. These earlier times where we're actually seeing the curve, like the bend in the curve, have to do with how much time you need to read the paper. So let's take a look at the specific, let's look at this in a little bit more detail, and I'm going to sort of focus on the difference between this like decline in ultimate attainment from birth compared to the other two options, which involve this optimal period, right? Where as long as you start learning within the optimal period, it doesn't really make any difference. Let's just like redraw them like that, right? Now, the assumption has been that if you see a curve like this sort of pinkish one here, then that's actually reflecting a continuous change in learning ability that also starts from birth, right? So like every day you are older, not only will you ultimately attain less of the language, your current ability to learn, a 1-year-old learns more slowly than a 0-year-old, but faster than a 2-year-old, et cetera. And similarly, the thought was that the learning ability is really tracking ultimate attainment. If you have one of these optimal periods, if you have to start learning before the age of 10 in order to reach native-like performance, then that's because at the age of 10 you start learning more slowly. Maybe it's this gradual, a relatively rapid drop. Maybe it's like a sort of like complete break there at 10 years old. But in any case, like the important thing that is happening at the end of the optimal period. So I generated, here's a synthetic ultimate attainment curve. It's generated from a model that I'll be describing later. The details of the model don't matter right now because the point sort of follows no matter what, like how you do this analysis. But here we have one of these continuous declines in ultimate attainment as a function of age of first exposure, right? And I actually generated this with a model where the underlying learning ability also changes continuously with age from birth, right? So this is basically what people, how people had thought ultimate attainment learning ability related. Here, though, I have managed to get an ultimate attainment curve that shows one of these optimal periods, right? With no real change before the age of about 10. But I also have a learning ability that is declining continuously from birth. And what's going on is, again, remember how I said that the shape of the ultimate attainment curve really depends on how long the activity takes, right? So, and I compared the ultimate attainment curve for reading a long paper versus reading a short paper. That's basically what's going on here, right? So either we're, on the right, learning is relatively fast early on the left, it's relatively slow from the get-go. And that is what actually, is the critical difference in these ultimate attainment curves. So it turns out that I can also generate very similar looking ultimate attainment curves, one of which, declines continuously from birth, one of which has an optimal period, from underlying learning ability curves that have really sharp changes in learning ability, right? So now in both cases, I have, I think up to about the age of 17, no change in learning ability. But the difference again is really just how fast that initial learning is. So notice by this logic, you can actually have quite a bit of age-related decline in learning ability without necessarily any change in ultimate attainment at all. Right, so older people will take longer, but still get to the same place. So you don't want to conclude from a lack of change in ultimate attainment as a function of age that there's no change in learning ability any more than you want to conclude that everyone who finishes a marathon ran at exactly the same pace. So the take-home message here really from these analyses is the studies of ultimate attainment have almost no bearing on current theoretical debates about language learning in critical periods. And I think this point's actually been underappreciated, which is why I'm belaboring it a bit. It means that despite half a century of intensive research, we actually know very little about critical periods or not critical periods in language acquisition, because they're basically measuring the wrong thing. So some of you might wonder, okay, well, why didn't we just, why were people measuring ultimate attainment anyway? Like if we wanted to measure learning ability as a function of age, why don't we just bring people in the laboratory, different ages, and teach them a bit of some new language and just like see how fast they learn, right? That'd be the obvious thing to do. The problem is that initially adults learn faster. This is true of basically any laboratory, any lab-based language learning experiment that has ever been published, essentially, the adults learn faster. And it's not just about being in the laboratory. So studies that have looked at, the initial periods of learning among immigrants also show adults, basically older people learning faster than younger people. So old kids learn faster than little kids, and adults learn really fast too. And maybe that's not actually surprising in retrospect, right? Adults and older children have access to better learning strategies. They have more attention span. They stay on task better. So anyway, so presumably if we waited long enough, we would see the littlest kids catch up and surpass the older learners. But the problem is we're talking about the scale of many years. Which is just very hard to run those studies. Because even if you look out toward, after 1 year, the adults still generally have done better. So another option is you could actually try to measure learning curves. And what I mean is first bring in a whole bunch of monolinguals. So their onset age of learning is age 0. Test their knowledge of the target language. And you get one of these learning curves, how long it, cross-sectionally, how long it takes to sort of hit the ceiling on that language. And you can bring in people who all started at the age of 1, and maybe their learning curve looks exactly the same, right? Maybe it makes no difference if you start at 0 or 1. But there should be some age at which, for people who start at that onset, we see a more shallow learning curve where people are hitting not quite the same ceiling, maybe learning, their trajectory is slower. And again, we know this is the case because we know just that if, people who start later do, ultimately past some age, not get to the same ceiling. The problem is that to measure these learning curves and compare them, which you would have to do, you have to measure them pretty precisely. And that's going to require hundreds of thousands of subjects or really, really precise measures of individuals. Which we generally don't have, right? So maybe if you got, 20 hours of testing for each individual, you'd measure their knowledge very, very precisely, and then you'd only need tens of thousands. But anyway, you need a lot, and that's why it hadn't been done. So we did it, and this is a paper that I mentioned, published in 2018. I'm going to talk a bit more about that and get it on the table. And particularly the results, which is we found was a fairly sharp decline in the rate at which syntax is acquired at around 17 to 18 years old. Now, this study has engendered a number of commentaries and follow-up studies, analyses. I am going to then talk about some of the ways we've been addressing the concerns that have come up, and which has all led to me lately thinking a lot more about actually understanding age-related increases in learning. Remember, I said earlier, during initial stages of learning, adults learn faster than kids, older kids learn faster than younger kids, and that's just not something that I think has really been paid much attention to. It's something that my analyses certainly pretend isn't true. And so it's something that I've been trying to understand better, because I suspect that, well, first of all, there's something interesting going on there that we understand, but it may also be an important sort of like, not exactly confound, but it may be muddying the waters of what's going on. Anyway, so as I said, we're going to take option 2, measure learning curves. We do this by, we designed this online study. that is, looks like we have these multiple choice questions, but they're all choose all that applies. So actually, this question here is actually 4 binary questions, right? For each of these possible, fill in the blanks. Would it work in that sentence context? So we have a number of those. We end up with 132 binary judgments. 95 of these are dialect independent. That means I believe we looked at 11 major English dialects, and in every one of those dialects, a majority of native speakers gave the same answer. We did have a lot of items that actually are variable across dialect. A lot of those were on purpose. I'll explain why in a moment, although some, we did not know about and discovered. This is actually a confound that I suspect a lot of prior studies have actually had, which is often when you're looking at L2 learners of English, they have been taught different varieties of English at different points in their life. And we got some detailed demographics. So in the initial paper, we had not quite 700,000 subjects, of which the most important ones are 250,000 native monolinguals. This does not mean that they didn't learn a second language sometime later in life, but when they were little, they were only learning English. And we have 45,000 immersion learners. Some of these are simultaneous bilinguals. Others are sequential bilinguals. But critically, they learned English in an English-speaking country. So if they're, so they're all immigrants, they did not really know, they hadn't studied English before coming to an English-speaking country. The non-immersion learners are the opposite. So these are L2 learners who have never spent substantial time in an English context. And they came from all over the world. And we had a wide range of ages and ages of acquisition and native languages. So here's the learning curves for monolinguals in red with M's and simultaneous bilinguals in this sort of like tannish color with the zeros marked there to mark their age of onset of being 0. You can see there's a difference between the monolinguals and simultaneous bilinguals there. It is significant. It is tiny. It's like in the order of like a quarter of a question correct, but it is significant and it's there. So let's look at the people started at ages 1, 2, or 3 in an immersion context. They don't look any different from the simultaneous bilinguals, right? And again, our x-axis here is years of experience, right? So 5 years of experience, if you start at 0 or start at 2 or 3, doesn't seem to make any difference. Here's people started at ages 4, 5, and 6. Again, not significantly different. 7, 8, and 9, not significantly different. People started at ages 10, 11, or 12 was the first curve that's actually significantly more shallow than the simultaneous bilinguals. And it just gets more and more shallow after that. And we actually see something very similar for the non-immersion learners, right? So here the curves for in tan there are for people started by earlier than the age of 10. They are statistically indistinguishable from one another. Starting at I forget if it's at 11 or 12, we start getting progressively more shallow curves. Now, this does not mean that the ability to learn declined at 10 or at 11, right? Because if you think about it, it's taking people a while to learn English. If the ability to learn declined at age 11, then people who started at age 10 would have only 1 year learning at the faster rate, and after that, they'd be learning more slowly. So we should see for people who started at age 10, a difference between them and the simultaneous bilinguals, right? So the fact that we're not seeing a clear difference until we get to people who are starting to learn at the age 10 or so, 10 or 11, means that actually the decline in ability to learn is somewhat later in adolescence or adulthood. And we're going to try to figure out exactly when that is. So intuition here for the analysis is that learning is a function of rate R and the amount left to learn. This is basically, this is an exponential decay model. Lots and lots of things in nature work this way. The intuition for language would be something like, during the first year of learning, you learn the high frequency, easy stuff. So obviously your rate of learning is going to go down in the second year because what's left to learn is just lower frequency or harder. So we're going to model people's grammatical syntactic knowledge at age t, time t, as 1 minus e to the negative rt, where r is the rate, the learning rate, and t is the number of years they've been learning. Now, of course, we have to take into account the fact that some people didn't start learning at age 0, right? So actually, we're going to do t minus onset age te. And this actually fits the data quite well. So for instance, here's in monolinguals, the ground truth data is in those little circles. The dashes are the best fit exponential decay model. You can see it fits the curve really, really nicely. Same is true for simultaneous bilinguals. Just show you again here that the simultaneous bilinguals, their curve is a little bit more shallow. It's harder to see in this graph because I've compressed the y-axis a bit. And that brings up an important point, which is that if we fit, like if we use the same learning rate R for monolinguals and simultaneous bilinguals, they would end up hitting the same ceiling, which is not what we want because we know they're different. So we introduced this thing called the experience discount factor. This is a number that ranges between 0 and 1. We fit it, it's set at 1 for monolinguals, and then we fit it for simultaneous bilinguals, for immersion learners, and for other immersion learners, and for non-immersion learners. This is basically saying we have 4 different R's, essentially, because E is just multiplied by R. My intuition is that this is basically reflecting the fact that you're just getting less input in English if you aren't a monolingual English speaker. But E is basically going to soak up any categorical differences between the learner types. Now, finally, there are these shape parameters, which I used to say don't worry about, but I'm going to tell you actually, we are going to worry about them later, but for right now, don't worry about them. The critical thing is we're going to let R, the learning rate, change with age, right? Or we're going to allow it to change with age. We're not going to force it to change with age. It could stay steady. We're going to assume that it's initially high, right? So up to some critical age TC, it's going to just be this R0. And then it's going to decline sigmoidally. So sigmoid is one of these S-shaped curves, right? They can be steeper or more shallow. And they have a couple parameters that determine how steep or shallow they are. And that's it. And then we fit all the parameters. So it turns out that this curve for R that we're using can fit a number of different hypotheses about how learning rate might change with age. So here in these panels, I've just actually drawn by hand a hypothetical, a hypothesis about how learning rate changes with age, and just fit it with that formula for R. And you can see we can fit a number of very different kinds of hypotheses pretty well. I want to point out finally, this is basically a fancy nonlinear regression, right? So we don't actually have in here, we're not instantiating any theory of how learning works. We're really just doing essentially a regression and fitting parameters, and we're going to interpret the parameters just like in any regression. That's just a lot more complicated than your typical regression. Okay, well, here were our results. Here is our best fitting curve for learning rate, with this really sharp drop of about almost 50% in learning rate at around 17 and a half years old. And this actually fits the data pretty well. So this is, again, this is the actual data. This is the fitted curves. You can see it's really capturing a lot of what's going on in the data. And in fact, in terms of R squared, in terms of fitting the curves themselves, R squared, I believe, is around like 0.88. That's not fitting the raw data. The R squared is not great because this was not a long test. And so we have a lot of variability from person to person. That's random noise. Once you average and get the curves, we're capturing those curves very well. And these results are problematic for basically every non-trivial theory that was in existence, in part because the theories that existed were all built around trying to explain why learning rate declines at puberty, or why learning rate declines at 5 years old, or why learning rate declines at 0. So those were the major, empirical claims out there, was that learning rate for syntax declines at either 0, 5, or 13. And theories were built around explaining one of those, and none of those appear to be the case, right? So that's problematic for any theory that had made an actual prediction. Just to give you a sense of this, there's been a lot of discussion of how, maybe the change in ability to learn language has to do with changes in other age-related changes in other aspects of cognition. Well, here's vocabulary. There is really just as sort of a baseline. We have 2 measures of working memory: visual working memory, verbal working memory, and digit symbol coding, which is sort of a measure of speed of processing. And you can see that working memory is sort of flat between the ages of 20 and 35. So that doesn't make any sense at all. We do see a decline in digit symbol coding at around 18. That's sort of consistent, except for we see this enormous increase in digit symbol coding before 18. And when I said that, older learners learn faster, I don't learn that much faster. So that doesn't fit very nicely either. There's some other data I have looking at 3 different measures of cognitive control. Again, all of which, none of which show like sort of consistent ability and then a drop in late adolescence. Here's a vocabulary again in that sort of purple color, and then a whole bunch of measures of social cognition and pragmatics, which also show other patterns. Basically, nobody has presented an analysis of any age-related change in any aspect of cognition that matches what we're seeing for syntax in our data. Okay, so that was blast from the past, 2018, many years ago. As I said, this is now received a fair amount of responses and both reasonable and maybe unreasonable concerns raised. I'm going to go through some of them because to show you sort of what we've learned in thinking about these concerns. And the first one I'm going to focus on is this, which is the most recent, came out basically over the new year or late fall. And they basically, were concerned about 2 questions. One was, does learning ability really decline rapidly with age? They were skeptical. And is the decline discontinuous? Which I think they mean, do we really have evidence of a sharp drop at 17, 18 years old? So there's actually some issues with this paper. Turns out the analysis doesn't make sense, actually. The statistical results are all in the wrong direction. They actually show strong statistical evidence that their hypothesis is wrong. And even if it were right, it turns out that the whole discussion amounts to distinction without a difference. So normally I wouldn't go through this in detail, but there's a few reasons I think it's worth doing. One is it turns out that explaining the mistakes in this paper are actually really helpful in understanding our data, understanding our analyses. I actually learned something about both. Like, I feel like I understand the data and I understand like what I did better, having thought through these reanalyses. And also, the paper's gotten enough attention that various folks have persuaded me that I have to talk about it. So I want to talk about it because you probably heard about it. Some of you anyway. So I'm going to start with basically the analyses. So they set out to compare a continuous model of the data and discontinuous model. And this takes a little unpacking, because what they mean by discontinuous model is just the actual model we used in 2018. Their continuous model is the exact same thing, but where the critical age has been set to 1. Except for in some analyses, they set it to 0. I suspect that was a mistake. I think they meant it to be 1 everywhere. But in any case, it doesn't make any difference, it turns out, in terms of the analyses. So again, what they're not really sort of comparing different sorts of models. What they're really asking is this free parameter of TC something that is justified by the data, right? Does it fit the data better to let that be a free parameter, or should we fit it at 1? Just leave it at 1. And I say this is not really about continuity. There's 2 reasons for that. One is that really their continuous model is just a special case of let's call it the discontinuous model, but actually let's call it the HTP model, Hartshorne, Tenenbaum, and Pinker. But also, as I showed you before, HTP actually can get fairly continuous declines with age, right? So it's not actually, it doesn't assume any discontinuity. It actually is testing whether discontinuity is, fits the data better. And there's actually, that's not really what we had intended to do in our equation for R. So we remember we have basically, you have a straight line and connected to a sigmoid. And the reason we did that is that sigmoids are symmetric, right? So if the initial decline is sharp, it has to decline to 0 sharply as well. If the initial decline is gradual, then it hits the bottom asymptote gradually. So a sigmoid by itself just can't entertain the possibility that learning declines slowly at first and then speeds up, or declines quickly and then slows down. And basically by doing this breakpoint, not exactly breakpoint model, but this disjoint model with a straight line and sigmoid, it was basically a way of hacking an asymmetric sigmoid while retaining some of the mathematical properties we needed from a sigmoid, which was that it's integrable. If we don't have an integrable function for R, then it turns out the math's just intractable. So anyway, just to show you here, these 2 things that I have highlighted here are really, the difference between them is just that is basically what TC is, right? TC is 20, I think, in the middle top and 0 in the top right. And that's sort of TC being the breakpoint between the straight line and the sigmoid. Similar things going on down here. So again, this is not all I'm going to say about the analyses, but it's not clear that they're testing what the authors thought they were testing. But leaving that aside, what did they find? Oh yeah, so sorry to say this, but leaving that, so it's really what they're testing is the decline asymmetric, right? Do we have evidence of an asymmetry in the age-related change in learning? And what did they find? Actually, they find overwhelming evidence for the asymmetric model, or what they call the discontinuous model, which is 10 to the 5th times more likely than their continuous model. So yeah, apparently the decline is asymmetric. Although what they conclude from this is they say something interesting, which is they say, well, a priori, we don't believe the discontinuous model. The evidence favors the discontinuous model, so we're going to call it a draw. And that's basically Bayesian reasoning. It's not, as a Bayesian, I can't really argue with the idea, except for the strength of their results. Basically, they're saying a priori, they thought there was that their continuous non-asymmetric sigmoid model was 10 to the 5th times more likely a priori. So, almost, basically, very close to ceiling in terms of their prior. So they're basically stating that they thought there was never any chance the discontinuous model could be right. I think that's an overly strong prior. What they do, though, next is, I should say, so these numbers I'm putting up here, these are not actually right. So there's most of the numbers in this paper are actually incorrect. I'll only mention the ones that change the conclusions. I'm submitting something hopefully next week that will have as an appendix, the right numbers for or the explanations of the mathematical errors for the most part, except for this table. So I'm taking tables straight from their paper. But I just want to say, I've redone these numbers to get the right ones. So step 2 is they argue that it wasn't a good idea to put all the learners of different sorts into the same model, right? So it doesn't make sense to analyze the monolinguals, the simultaneous bilinguals, the immersion learners, the non-immersion learners all together, because those are really different sorts of learners, and maybe maybe there's, sharp declines in learning ability with age for some of them and not for others. Now, I'm sympathetic to the overall concern that maybe these different groups really are very different, right? But applying the model in this way doesn't make any sense, right? So what the model is doing is asking, what age-related changes in learning do we have to infer to explain the difference in learning for people who started learning at different ages, right? So that, and then they're applying these models to people who all started learning at the exact same age, right? So this is a little bit like saying, I have a hypothesis that children grow with age, older children are taller. Somebody else has a counter hypothesis that no, they don't, they all stay the same age. So we're going to look at all kids who are born on the same day and show that there's no relationship between the day they were, like how old they are and how tall they are, which of course there isn't because they're all the same age. Leaving that aside, though, it turns out in no case do they find that the continuous model is significantly better. There are a number of cases in which the discontinuous model, so the original model, fits significantly better. More importantly, the model differences are actually are super minimal. And this is, which I'll get back to in a second, but so again, like the analyses, it's not clear exactly that it's testing the thing they thought they were testing, and the statistical results are in the wrong direction. Let's look at, here's in black, I have the best fit for the discontinuous model. And then the best fit for the continuous model is in the red dashed lines. And this is just applied to monolinguals. So you might say, oh, well, that looks really different, right? We see this huge drop in the continuous model at 50 years old, and the discontinuous model shows no drop at all, which is interesting again, because they're calling it discontinuous, but there's no discontinuity. But the thing is that monolinguals have hit ceiling well before the age of 50. It turned out the way that they had designed their model, it required for the continuous model, but not for the discontinuous model, they require a drop at some age. And 50 is the latest it can have a drop. So that's why it finds the drop at 50. If you actually look at the fit, what it says about the learning curves, these two models actually, there is a slight difference. If you zoom in a lot, pay attention to the y-axis there, you can see the discontinuous model predicts that that learners, monolinguals, hit an ever so slightly higher ceiling, but that's the difference. And it's, you really have to zoom in to see it. Something similar for simultaneous bilinguals here. Actually, both of them, both models show a drop at not quite 40 years old. But again, this is really like a distinction without a difference, because simultaneous bilinguals are already at ceiling well before that age. So if you like zoom in a ton, you can see the difference, but this is so small, there's no way that is significant. And in fact, it is not significant. All right, so just to recap, what was actually being done here was asking about whether the sort of decline in learning is asymmetric. It appears that it actually is. The statistical results, if anything, are in the wrong directions. For the most part, the new model doesn't fit the data very well, which is not shocking, since their model is really just a restricted version of the original model. And in the end, like the actual model fits are not really different in terms of what's claimed about learning. At least so far as we could see with the kind of data we have, right? You just can't tell the difference between is it really the case that 50-year-old monolinguals start learning their native language more slowly? Maybe, but how would you know? They're not learning anything. So the model actually holds up really well, but I did actually have a concern, which is I actually do take the question of, is the decline in learning really that sharp, right? So remember I showed you that, our formula for R could fit a lot of different shapes. Oh, this is actually not the whole figure. Here is an additional line, which is actually showing some cases where the model, which is in red, clearly infers much sharper drops in learning ability than is really there. Basically, from the construction of the formula, there's just certain kinds of curves that just can't fit very well. And so I did worry that, maybe, for artifactual reasons, we were seeing a sharper drop than there really should be. Now, using only a sigmoid is not going to work. We clearly have an asymmetric, change in learning ability. What we did is, instead of, joining a line and a sigmoid, we joined two sigmoids. It turns out this retains the thing that we really needed, which was that the curve remains integrable. We have to integrate in pieces, but it's not a big deal, but it's a whole lot more flexible. So this is how it actually, you can see how tight those like red lines are to the black lines. It fits, it's a very, very flexible curve that can fit a lot of things, much better than our old one could. So anyway, we reran the analyses with this new formula for R. Here are the differences. The old model is in the dashed line, the new one is in the solid line. You can see there's basically no difference. We were not inferring, our model wasn't inferring a sharp drop in learning ability because of some artifact of the math. It's inferring a sharp drop in learning at around 17, 18 years old, because that is what is actually needed to make sense of the data. So again, this seems to, some of these original assumptions that in the modeling that I was not super comfortable with turn out to actually have held up pretty well. Real quickly, I want to talk a little bit about something that I do not have a response to. Because Mike Frank was concerned that that there's maybe an artificial ceiling in our data. One point he raises, which I'm actually just going to gloss over, was use item response theory for analysis. I actually think that's a good idea. We did it and made no difference. But the theoretical point is, he points out that our analyses assume that there is a fixed amount of syntax to learn. Right, we have this exponential decay, and it, the amount left to learn decays to 0. Right, and for many, that makes sense for certain classic generative oriented theories of language acquisition. But if you ascribe to a construction grammar approach, syntactic patterns are really just they're like vocabulary. There's no fixed amount, and there's presumably always more out there that you could in principle learn, but the model just can't. It assumes that that everybody is going to the same asymptote. I'm going to actually skip that because I want to talk about something else more interesting, which is this last bit, which is understanding age-related increases in learning. As I said, I've been sort of worried about this because it's something that is, we know is true of learning, and it's certainly not addressed in our analyses, right? Our curves assume that learning rate can only decrease, it can't increase. That's actually, it's a computational limitation. I've just not found anything that's tractable that allows for learning to go up or down. We need more constraints, basically, just like a completely unconstrained curve for learning rate that just can move all over the place. It's just too unconstrained. So I've been trying to understand, how could we constrain that hypothesis about, how much the learning rate could go up and when. So one thing I've been thinking about is also related to this is the different asymptotes, right? So the simultaneous bilinguals don't hit quite the same ceiling as the monolinguals. This seems to maybe be specific to syntax. So if you look at vocabulary data we have, we don't see a difference like that that's significant. Here we have shaded error bars. You can see we have complete overlap between the monolinguals and bilinguals. In the model, we basically handle this by letting learning rate go to 0. So the bilinguals eventually stopped learning. So did the monolinguals, but the bilinguals just stopped learning at a lower rate because they've been learning a bit more slowly. But that seems wrong to me. I'm not convinced that 50-year-olds can't learn anything about a new language's syntax. So it'd be nice to have a more principled way of explaining and explaining specifically why in syntax we're seeing these different asymptotes. I'm bringing that up mainly as a puzzle that I haven't made progress on. What I have been making progress on is this issue of accelerated learning for simultaneous bilinguals. So this is a large CDI data set. And you can see, what's typically remarked upon, which is that as a function of age, simultaneous bilinguals are learning more slowly. I believe these are all, everybody's been tested in English for this study, although I can't say for sure because we're collapsing across basically a lot of data sets that people donated. But that's a function of age. And remember, bilinguals are learning 2 languages. If we take estimates, we used what parents had estimated as the proportion of input in each language for the bilinguals, and regraphed this as input, learning as a function of the amount of input. And you can see something very different, which is for the first 15 million words of input or so, the bilinguals are actually learning faster. The monolinguals do eventually overtake them. And what could be going on there? Well, probably transfer, right? So they've learned some words in one language, and this is helping them learn in another language. This is something that we'd really like to try to quantify better in order to, again, understand, what we should be saying about this, if nothing else, for like analysis. So this is vocabulary. We have been working on this project with international schools. So we presented BUCLD this last year, data from 855 English learners. Now, international schools are a nice place to look at later learners of a language, because where you're interested in their native language, because one of the concerns that I have about studies that compare learners of English who have different native languages is cultural differences and how they're being exposed to the language, exposed to English. International schools, sort of by design, are meant to be pretty similar one to the next. It's not perfectly controlling environment, but we know that these learners are getting their English primarily in school, and the schools have similar curricula. What we have is only a holistic standardized English test. It sort of lumps vocabulary and syntax and pronunciation all together, unfortunately. But what's nice is it is standardized and it's long, so it's a pretty good measure of these individuals. Here's almost half are native Arabic speakers, but we do have a good distribution of native languages. And what we're interested in is looking at the effect of how similar their L1 is to English, which we measured using genetic distance, which is this measure based on Levenstein edit distances between word lists, which is definitely not ideal, but it's currently the only game in town in terms of measuring distances between different similarities between language. If you look at the kids who, this is confusing every time. I'm just going to fix this right now. Ta-da, much better. So if you look at the kids who started learning English at age 5 or at age 7, we have 3 different lines in each case, depending on how dissimilar their native languages to English. You see the lines are on top of each other. There's really no effect of what their native language is. We do start seeing a difference for those who started learning at 11 or 13. Obviously, the number of subjects is smaller, but what we're seeing is that the more dissimilar, the faster they're learning. And actually, that accounts for almost all the difference in older kids learning faster. So for kids whose native language is not that similar to English, being older doesn't seem to result in learning any faster, especially, but if their language is similar to English, there we see the older kids are learning faster. So that I think is some prima facie, evidence of transfer that may, and potentially, saying that, the reason that One of the reasons that older learners learn faster, at least at first, is because of transfer from the first language. The question is eventually this transfer, in fact, what's causing slower learning later on? Right? Maybe initially, if you haven't learned very much about your native language, but you've learned, languages have words, right, and word order, something like that. That's so general, you can transfer that, and it works pretty well, particularly if your native language is reasonably similar to the target L2. As you learn your native language, better, now you're starting to get, that the more narrowed priors on what language is like, and the transfer is hurting you. Of course, then we want to explain, why does it seem to be, only really start to hurt you relatively late, right, in late adolescence. Although our exact measure of that age might change if we are allowing, learning ability to actually, or learning rate to increase earlier in age. Anyway, that's sort of where I am and what I'm thinking about. I do not have an answer at this point. What I was trying to convey and get feedback on is sort of where we're going and what we're trying to do at this point. Thank you.
Thank you, Josh. That was great. So we have time for discussion. So Mary, I'm not sure who is first, but I need to get I think Mary was first. Can you unmute yourself, or you could put it in the chat as well? No, Mary? Okay, then Therese, I saw you had your hand raised.
They might have just been clapping.
Okay. No. Anybody with a question? Well, maybe I can get started. So if I understood the last part of your talk correctly, so you find that for those whose language is dissimilar to English, that initially and for the older kids, that the learning rate is slower, but then later it's faster. Did I understand that correctly?
Yeah, no, sorry, that went by fast. Basically, if their language is very different from English, then the rate at which they learn is more or less the same, regardless of when they started learning. It's for those who speak languages that are the more similar their languages to English, the more we see a speed up with age, with the kids who are basically entering school older, learning faster. And that was why I was saying, this potentially, I had hand waved at the beginning of the talk, so it's been reported that older kids learn faster than younger kids, and adults learn faster than kids, at least in the first year or so of learning. And this is something that, is again sort of reported and ignored, I think in part because it just doesn't fit in with the debates folks are having. But it's there, and it's weird. And I hand waved something about, adults have, explicit learning strategies, blah, 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 right? But what we're seeing is some evidence that maybe actually what's going on here is really transfer, right? The older learners are learning faster because they're transferring from their first language. Then we have two possibilities. One is that maybe the older you get, the less well that works. Another is that actually the more you learn of the language, the second language, less well it works, right? It gets you started. Because I think we all know for most languages you try learning, a word for word dictionary translation is not a horrible strategy. I mean, it's terrible, right? That's not the end state that you would want, but you actually can communicate that way, right? But you can only communicate that way if you have a dictionary, right? So you have to have already had that first language to even do the word for word translation, if that makes sense. Anyway, that's my story I got right now, but obviously what I'm really hoping now is that we'll be able to there are other standardized tests that some schools use that really do break things down in terms of syntax versus, phonology or whatnot. And that would be a whole lot more helpful. Unfortunately, the people who make those tests have been less helpful than the people who make WIDA, which is why that's where our data are from right now.
Yeah. So so since you're looking at kids, it might also be interesting to look at cognitive control and development in cognitive control and how that relates to language learning. So you showed
Yeah,
earlier, these graphs that, if you look
mm,
at over the lifespan, that, the language learning and the cognitive control graph just don't seem to match, but it might be in kids that it does relate somehow.
yeah. So um, yeah, let's pull that up. Um, sorry, yes, that's this one in the middle there, the flanker, Stroop, and Simon.
Hmm.
Um, yeah, I think so. This is the work I'm doing with Chris Erb, and I think part of what we've realized and working on this is that we are deeply confused, and we think the field is deeply confused about the underlying latent structure of these tasks.
Hmm.
And so translating this, like something complicated is going on, and people probably haven't worked out correctly what the underlying latent factors are and how they interact. So we're really looking at, changes due to the changes in performance on the task, but what we really care about is changes in other underlying mechanisms. And I think we're running some more experiments to see if we can get a better handle on that. I mean, that is tricky because it is an area, well, it's one of those areas where the theories are pretty good again, but the data is not great. Simply in terms of looking at like age-related change, because there's just not been large data sets before. So anyway, that's what we're working on. I think, this is sort of why I said that I think like our results are problematic for trivial theories. For the non-trivial ones where you're like, well, let's not take like, age-related change in some cognitive task as representing age-related change in underlying mechanisms. Then, and also when you start thinking, actually, Stroop involves some learning, right?
Hmm.
Even like, working memory involves learning. So are we really, when we do a working memory test, we're partly measuring people's like current working memory ability, but we're also measuring the learning they've done on working memory related tasks up until that date. And that decomposition, I think, is something that's going to be both technically and theoretically very challenging. And I think is certainly something that needs to be done for us to make progress there. So that's my way of saying yes.
Thank you.
So I'd like to ask a question, basically with the starting premise that many of us here at UF are interested in heritage speakers. And we know we have a large community here in Florida that would be classified as this group. What seems to be really striking about the group is that age-wise, they are getting that exposure to very early input, yet some would certainly classify them as having very different outcomes on syntax precisely. Phonology seems to be okay in comparison, or maybe let's put it more similar to, say, a monolingual comparison. And there are lots of issues about whether monolingual comparisons are right or wrong, etc. But I'm just wondering, because certainly in the Boston area, there are lots of heritage speakers as well, whether you have had some thought about this group in particular in relation to these learning rates. And I mean, I suppose they are part of, they're at least some subset of these data sets that you have.
Well, I mean, for the immersion learners, they're especially like basically if you were a young immigrant, you are basically by definition that's how we usually define a heritage learner, right? Or someone who is born has in the like new country, but has immigrant parents, right? So yeah, definitely the immersion learners. A lot of those are heritage speakers. I think this is something that James Flegge like brings up a lot when I talk to him. Not surprisingly, we do not have good information about these folks' language history. And I think it's totally reasonable to wonder if, it is almost certainly the case that some of the differences that you see and with age of first exposure also have to do with differences in input, right? And differences in like the degree to which you bother retaining the first language or whatnot, which is probably also dependent on the age at which you start. right? Measuring that is super hard retrospectively. I know folks try to do it. I'm not a big fan of the measures. It's something that is impossible to do through the modeling, because basically you end up not being able to disentangle changes in learning rate or learning ability with changes in input if you allow both of them to change with age. Where I've been interested in this, one, this is part of why I'm interested in the international schools, because I feel this is a nice population and that they are presumably continuing to speak, the local language at home and on the street, and English is in school. This does not help us understand heritage learners, right? But helps maybe decrease some of the noise we're dealing with. The other thing I've been looking at is working with some basically language learning apps, which is not going to get quite the right population that you're interested in here, but inserting basically into their apps some questions to people about motivation and amount of time that they are spending. So if we had a really nice demographically diverse fine-grained measure of how people, at least on average, people's motivation and amount of time being put in the language changes with age, then we could use that as an external constraint on, on our analysis. So that's sort of what I'm thinking about. But I don't know, what do you think I should be thinking about in terms of heritage speakers?
Well, it's more, I just want the answer, honestly, because there just needs to be something, just on paper, the input is there, they're in the critical period. So, as you suggested, it probably has to do with the input they're getting, perhaps the community that they're in already has divergent syntactic structure. So it just becomes a part of the language change that's baked into the heritage language itself. But how do we capture that? And, I would extend one additional scenario to the one you mentioned about just immigrants. We could also claim this just between majority and minority languages. So for native languages in the US as well, we might consider those children born into those communities as heritage speakers, even though there's no immigration in that scenario, because there seems to be this power dynamic between the languages as well.
Yeah. Another thing along those lines that we have definitely been hitting with our international school project, something that is actually both an opportunity and a problem for our analyses, is the demographics of international schools changed dramatically in the last 2 years, right? So a lot of schools used to be much more diverse in terms of L1 and now have much more narrow range of L1s. And what teachers are telling me is they are losing the battle of speaking English in school, right? Because if you have 20 kids in 10 native languages, they speak English. If you have 20 kids in 2 native languages, they speak those 2 native languages with each other. And I think there too, thinking about what is the community this learner is in? Are they, a Swahili speaker in in Northern Idaho, or are they, in New York City, right? That's going to look very different. All right, I can take the one last question and then I need to jot.
Eleonora, that's you.
Yeah. Hi, thank you so much for your talk. Very quickly, maybe connected also to what Edith was hinting at. So I love the fact that you're trying to capture data also from, younger adults, but really almost adolescents. This age is vastly understudied. And then I would like to connect to my question, which is wanting it, I think, meta-linguistic awareness could play potentially a very important role in learning patterns, because especially to look at the difference that you mentioned between adults and younger people. So we know that meta-linguistic awareness varies a lot, even throughout childhood and young adulthood, but also in adulthood proper. And yeah, in another study that we have conducted, we know that meta-linguistic awareness can predict actually a whole set of other cognitive and linguistic features. So I wonder your thoughts on that, because it's so important, I think, for language, for learning, or acquiring a new language to think about how you do that in terms of meta-linguistic awareness. So I just wonder, just even a hint of your thoughts, and then, we can chat more another time. Thank you so much.
Yeah, so the closest to thoughts that I have are the following, which is one, there is definitely a clear effect in our syntax data of education, right? And it's actually like good sized, it's several times larger than the difference between, say, monolinguals and simultaneous bilinguals, for instance, with people with more education doing better on the test, which could be, they really know the language better. It could be they're better at taking tests, right? There's all kinds of, things that might be going on there. And this is something that we have ignored, but is part of why, again, I'm, deeply worried about a lot of the studies that look at differences between different L1s and their impact on learning L2, because very often your L1 is not randomly distributed with respect to socioeconomic status in education either, right? Which is part of why I was, excited when this, undergraduate thesis student, came to me with this idea of looking at international schools. It's like, oh my God, that's like an obvious thing that we should be doing. And this is one of them, right? Is that you're, not controlling cultural and SES differences perfectly across, these, within the population, but like way better than you are with just like, convenient sample. That is, again, I think, similar to the answer I gave to Jorge, that I'm basically avoiding the problem by trying to get rid of it rather than trying to understand it. That's sort of like the extent to which I have like thought about it. And yeah, I was dead. I'm sorry that it ends up being that I don't have a ton of time to stay and talk. I would love to hear more from people. Basically, I got into bilingualism quite roundabout, not starting from wanting to study it, starting from I have a method of getting like crap tons of data. What should I do with it? Right, and I was like, oh, critical periods. That seems like a good thing to do. Right, and now because that that was one of many projects I was trying, and it's the one that like really took off. And so I'm like, okay, apparently I'm a bilingualism researcher. So I'm really interested. So I have a lot to learn. I'd love to hear from you all, your thoughts, right?
Can I just say something real quick? I know you're going to run. Thank you for your talk. It was actually really instructive to hear you talk about how you came to this and how you think about bilingualism. And I was very happy to hear you say what you said in response to Jorge about the importance of input factors, exposure factors, all those soft things that are really hard to capture retrospectively, even concurrently, they're hard to capture. You just can't do it with your big data approach. And I appreciate your big data approach. But I always worry that you then, just because age of acquisition is an easier number, an easier construct to slap a number on, that then that's what we place our focus and our attention on. And I think that's what's really derailed the whole field, and not just the fields community thinking about this. So if you could just acknowledge that there's other things that you acknowledge matter, but you cannot capture, and I understand you cannot capture. I think that makes me perceive your work very differently from hearing you say what you just said. Sorry, that was much longer.
I think something I was drilled on as a graduate student is always thinking about the linking hypothesis. What we have measured is age and outcome, right? But that could be, basically anything, right? Like, it doesn't mean that age was the like critical factor there. It's like something that correlates well with age. Now, age correlates well with age, so it might be age, right? It could be all kinds of other things too. And so, yeah, I actually don't think that, I actually think that the big data approach is very like conducive to worrying about some of these issues about the amount of like exposure or whatnot folks are getting, because as you say, it's very hard to measure, but not with, say, Alina, for instance. Now, Alina currently stinks at doing language detection, but it can be done, right? There are ways of like quantifying input. I think that I guess I'm starting from this an assumption that I know not everybody shares, which is that you need a lot of data to have robust results, and that constrains what I can currently do. But I don't think that the solution is, okay, let's like not collect a lot of data. I still think we need a lot of data. The question is like, okay, well, we can collect this kind of a lot of data. How, like, what's the next thing that we're missing that we need a lot on, right? And that's why, you know, I have this potential collaboration with one of these, like, you know, language learning apps on just like asking people's motivation, right? Which is also one of those things that gets tossed around. And I totally believe that motivation to learn a new language changes with age. Like, it really ought to. If people are not, like, if people are at all rational, you know, you should not be highly motivated to learn a new language at the age of 93, right? Like, that's just like probably not the best use of your time unless you just love languages or something. But it's clearly like, you know, in terms of how it's going to improve your future, not much, right? Because if you're a little kid, it's different. What I think, you know, really, they're just like, I've not been able to find good data on like, okay, well, how much does this change, right? When does it change exactly? There's a few studies, they tend to give very different results. But again, I think this is the kind of thing that like seems like low-hanging fruit, specifically because there's companies that want this information already, right? So it's just a matter of collaborating with them to get it. Anyway, so that's my defense of let's do big data everything.
So I appreciate that, and I think it's great that we have you sort of pushing this big data approach. I just, for it to be, I think perhaps perceived the way you mean it to be perceived, I think it would help, and I'm speaking sort of from the second language, a little bit maybe from the applied linguistics community, I think to embed it a little bit more and sort of making clear what the limitations are. I think I agree with you, we need what you do, but I think it's also important to emphasize that certain things cannot be gotten at with big data. That doesn't mean we shouldn't do big data, but there's those hard to operationalize constructs, like, and I think maybe actually motivation is one of them. Just slapping a quick operationalization at that and collecting lots and lots of data, what can we actually learn from that? I'm skeptical of that. I just haven't been convinced yet.
All right, well, thanks for the pushback. I'll think about it, and I'm happy to talk anytime, except for right now when I have students waiting on me and I really should go. But
Yeah.
great
Well,
talking to you.
Thank you so much, Josh. All right.
Thanks, Therese. That was great what you said.
Good to see you, Therese.
Yeah, sorry for taking up too much time.